Hello, everyone. Uh, let's give another 30 seconds for everyone to join in. Okay, let's begin. Hi, good evening, everyone. I'm Priyanka Palshetkar. I work as a data engineering lead at Bounteous Accolite, where I help clients solve complex data problems employing data architecture and modeling principles. Um, It gives me great pleasure to speak with you today. Welcome to our Tech Connect webinar. And if any of your friends and colleagues are unable to join this Zoom webinar, then our team will share the YouTube live stream link with you here, which you can share with them. So let's begin. So let me talk about the agenda for today. So today, the first thing that I'll be doing is talk about my company, Bounteous Accolite. Then we'll talk about what we are building today, like what is the problem statement that we are solving. Then we'll talk about hybrid learning in NLP because we are going to do hybrid text classification today, right? And then we look at designing the workflow for our problem statement at hand. And we'll explore the concepts that are involved in our problem statement solution. And I will do a code walkthrough with you. And the most important concepts that are involved here are unsupervised topic modeling, supervised text classification, and explainability in NLP, which is what I will be touching upon today. And then I'll also talk about what's next in this particular project for me and for you if you were to, like explore and do more. So let's begin. So let me tell you about my company, Bounteous Accolite. In February, Accolite Digital, a leading digital engineering, cloud data, and AI services provider, and Bounteous, a digital innovation partner of the world's most ambitious brands, announced their merger, creating a new end-to-end digital transformation services consultancy, which partners with leading brands around the globe to co-innovate and drive exceptional client outcomes. And our services span strategy, analytics, digital engineering, cloud, data and AI, experience design, and marketing. And we are guided by co-innovation and our proven methodology of collaborative partnership. Bounteous X Acolyte brings together 4,000 plus employees spanning North America, APAC, and EMEA, and partnerships with leading technology providers. So that's about my company. And let's talk about what we are building today. So today we are going to build a news articles classifier. And we have data on news articles, and we want to categorize these into meaningful topics or categories, which could be social category, crafts, music, and so on and so forth. And while we are building this particular model, like every other classification problem, one, we don't have any labeled data. So we cannot directly use this for a supervised model and train on it. So because we don't have labeled data. And secondly, we have to incorporate our domain knowledge and build domain specific categories when building this classifier. So what is domain specific? So let's try to understand that with an example. So take example of this particular news article. It talks about a new genus and snake species, which was named after Leonardo DiCaprio. So if I were in the entertainment business, then I would want to classify this article as under movies because it's about Leonardo DiCaprio. But if I was under, like I say, a natural or nature magazine or an environmental business, I would want to classify this as science because it is about a new genus and snake species. So this is what I mean when I talk about domain specific categories. And that's very important in business context because LLMs are trained on a lot of data that exists, but we want it to work for us. And that's what we are going to learn, how we can do that today and how we can guide the model. So, what is hybrid learning? Because we are doing hybrid text classification, right? So, let's try to understand that. So, you know what is supervised learning? Supervised learning is when a model learns from examples with correct answers to make predictions or decisions, right? So, you have an input output pair which the model trains on. And unsupervised learning is when a model tries to find patterns or groups in your data without being given the correct answers. So, what is then hybrid learning? Hybrid learning combines the best of both the worlds, both unsupervised and supervised, and it leverages their respective strengths for solving complex problems. So, we are going to use both these techniques today to solve our text classification problem. And how? So, let's talk about that. So, how are we going to design this workflow? Now, since we don't have any labeled data, we directly cannot do supervised modeling. So we will first use an unsupervised learning model. Uh, we will use topic modeling, which is our unsupervised technique, to generate labels for use by finding patterns in our data. And so we will give it input as news articles, and we will generate pseudo labels for these articles, and we will guide our model along the way to generate categories that are relevant for us as per our domain knowledge. And then we will take these high confidence labels from these labels and we will feed it as input to our supervised word classifier. So this is our supervised model. It will take the output of the unsupervised model and we would feed it and we would train our model to take the output input pair and finally generate our final news categories and labels. And obviously this process is going to be iterative and we would have to do multiple iterations of feeding the data and correcting the labels again and again until we reach a place where we are comfortable with the outputs of our model. So that's what we are going to do today. So let's talk about some of the concepts before I walk into the code. Okay, so we are going to do unsupervised topic modeling and we are going to use bird topic library for it. So bird topic, what it basically helps us do is topic modeling, and we are going to use bird topic to generate topics which are represented by top words and probabilities, which are our pseudo labels, and then we are going to feed those into our supervised model. So that's a unsupervised part of our workflow. And talking about the supervised part, I'm going to use Distilbert for our case. And why Distilbert? Distilbert is a lightweight version of BERT, which is an LLM, and it is optimized for faster training and inference. And it is already trained on a large corpus of data. So it has a lot of robust textual embeddings, which we can leverage on and don't have to, do anything from scratch. So I'm going to use Distilbert for sequence classification. The input to this model is like we discussed the high confidence pseudo label that we generated. Then we are going to fine tune this to learn our domain specific nuances. And then the output is our final classification labels. So this is what we are going to build today. So let me share my code so that we can talk about what we are going to do and learn. Okay. So I have prepared like a simple text classification model for this. And my goal is to explain what I have done so that you can download this particular repository. I've made it public for a later use. And then you can look at it and explore and work with it and so on and so forth. Okay. So let's look at the structure of our model. So we have a unsupervised Jupyter notebook where I'm going to build the topic model. And then we have the supervised notebook where I'm going to build our bird classifier on the basis of the output of this. and I have the requirements or the packages that I'm using in this particular building the models here stated. So these are the three main files, and this is the data file. So this data I have downloaded from Kaggle, and it is about news articles, and we're going to explore that soon. So let's start looking at our unsupervised part. So I will go through high level what we are trying to do here, and then you can explore in your own time and experiment with it and work with it and do better. Okay. So in the unsupervised topic model, first obviously we're going to load our data. So I loaded the JSON file here, and you will see that it has links, it has the headline, description, it has the category. But let's ignore that because real life examples don't have categories for us. So we are going to assume that these categories don't exist. So let's look at the headline, and I'm going to use the headline and short description texts to, as the textual data input for our unsupervised model. So I have combined the headline and the short description with a separator to create our textual data. So you can see my final output is textual data, which is just, texts. So I converted it into a list. And now we'll start building our topic model. So I'll keep it simple. So the three steps that we are going to do here is we are going to define the model, we are going to tune it, parameterize it in the definition stage. Then we will fit transform the model on our data, which is where the learning happens. And then we'll review the output. And on the basis of that output, we are going to, decide what we're going to do next so that we can tune it as per our domain specific requirements. Okay. So first, this is how I am going to define. I'm going to load the package. I'm going to load bird topic from it. I'm going to define plain vanilla bird topic. I'm not adding any parameters to this. And I'm going to fit transform using the fit transform command, give it my documents, which is my textual news articles. And you see the model generates two kinds of outputs, topic model. So it will give you information on what topics it has been able to generate. So you will see the name of the topic, you will see the words that it has used to, represent that topic. And you will see some examples of articles it is grouping under this topic. And you will see how many articles it has grouped under this particular topic. Now, clearly one problem that I see is the model has generated around 2000 topics. So I don't want those many topics. I want, say, like maybe 100 categories or 50 categories, right? So that is one thing maybe I would want to change in the next iteration. The model also gives you a list of mapping of the document with the topic that the model thinks it is linked to. So right now the article is about funniest tweets, and the model C has correctly kind of grouped it into a funniest tweet topic. But you can also see there are problems in this model. So you can see this is about clearly about Spider-Man, but it is grouped under some random topic, right? So we are going to go and fine tune this even further now. So first of all, like I said, right, 2000 topics. I want to just reduce the number. So what I'll do is when I'm defining the bird topic the next time, I'm going to tell bird topic, can you please reduce the number of topics to 100, which I'm doing by using NR topics here. Then I'm going to do fit transform on my documents, and then I'm going to again review the output. Now this time, if you see, the model will generate only 100 topics because you told it. And let's observe the top 10 topics, okay, which is what I'm doing here. So right off the bat, I can see that there are some stop words, or there are some words like he, she, it, they, which don't really add a lot of context to my classification. So usually we remove the stop words when we are doing any kind of text classification, unless and until it's like explicitly needed for your use case. So, but I don't want it. So I'm going to remove these words from my topics representation. So the next thing that I'm going to do is remove the stop words, and I'm going to use count vectorizer for it. Plus, I think 10 words to represent a topic is less. So I'm going to increase the number of words in a topic to 15. That's the next iteration that I want to do. So I'm going to define a vectorizer model, which is a count vectorizer. And I'm going to say, can you please remove the stop words? And I'm going to pass this vectorizer model to my bird topic. What it is going to do in the background is it's going to remove those stop words, he, she, it, they, and those kind of words which it has identified from the output that it generates from the topic representation. And I'm also saying, right, I want top 10, not 10, 15 words. So then I define the model by passing the new parameters. I fit transform it on my documents, and I then again review the results. So once I review the results, you see now I don't see he, she, it, they, and those kind of words because I've removed those topics. Now, while I was building this particular model, right, each of this iteration took around 5 minutes because it had around 200K articles, right? So I wanted to make these iterations faster so that I can experiment better. And in any kind of LLM that you build, the first step that happens is turning your text into numbers or representing it as vectors, which is creating its embeddings, right? And your embeddings are going to be basis your articles, and your articles are never changing, right? So what I thought was, let me pre-compute these embeddings so that every time I'm training the model, it doesn't have to, like build the embeddings again and again. So what I did was I chose the embedding model. This is the default embedding model that Bird Topic uses. Bird Topic has excellent documentation. You can read and you can understand it very easily, at least when you're applying. And then I created the embeddings beforehand for my document. So I've created the vector representations of my text beforehand. And then I'm going to pass it in the next steps directly so that my model understands that, oh, I don't have to create the embeddings again. They have already given it to me so that it is faster. That first step is done already. So every iteration after this would be faster. So that's what I did. And other thing that you can see from the output of the previous stages, there are some words which appear in multiple topics. Like you can see new appears in multiple topics. And I don't want that. I want every word to fall only in the one topic. So I want to avoid same keywords in the different topics. So how I'm going to achieve that is I'm going to use a representation model called maximal marginal relevance. Now you must be thinking, how do I know I have to use this only? We have to go and read the documentation. But topic you find for everything that you want to implement, you can go and find how you can do it and you'll find the documentation there. So that's how I find. I did not want the same keywords. So I searched the documentation. I found we can do it using this maximal marginal relevance. And I'm passing it diversity 0.5. What diversity means is how diverse your topics are. Do you want them to be same? Do you want them to be completely different? So that's what you're trying to do here. So I am going to pass a representation model of maximum marginal relevance. It is going to help me avoid same keywords. And then I also said that I don't want 100 topics and I want 20 keywords. I want to see more words now. So I defined my model again with all these new things, new parameters. Then I fit transform it and I passed it the pre-computing embeddings so that my iteration is faster. And then let's review the output from this stage. So now you will see that I don't have same words. You will not see same words in the same topics. Plus you will see that it has broken it down to 50 key topics and there are 20 words representing each of the topic. So you can clearly see that there are topics on fashion, food and health, pure voices, wellness, sports, and different kind of things. Now, so there was a keyword that I added in the beginning, right? This sep word that you can see, which I had added to separate the title and the description of the model. I don't want that word in my list. You can see that it is present in the top two topics. So you can see, I don't want this word. And there could be such 10 other words that you don't want the model to consider because they don't add value. So you can add those to your custom and make a custom stop word list. So you can add it to the English stop word list and say, oh, I don't want these as well. So that's what I did. And then I also added engram. What engram means is I don't want the model to look at each word individually. I want it to look at, say two words or three words together. And that's what engram helps you do. So what this engram is telling the model to is look at one word single also and look at two words also, like look at it in pairs also, so that it captures the context of the model. So if you just look at the word bank, you might think it is about, bank where you put money in. But what if the word before that was blood bank? Then that's a completely different context, right? So that's why I'm telling the model to, like use the engram and look at two words. Now that could depend on what your use case. It could be three, it could be more. And the more you increase, the heavier it would be. It would create an embedding, right? So that's what I told you. Like look at two words so that it captures the nuances of the text. And then again, I fit transform it, and then I'm looking at the output. So now you will finally see the sep word is not there anymore. Plus the model has looked at the context. So definitely the output that it has given has changed and has been better. Now I have 50 topics. Okay. So I would want to, like when I looked at these topics, there were certain topics that I thought could be merged together. So, like if you see the zero topic is about fashion, and then the 43rd topic, fashion and movies, sorry, and the 43rd topic, which was also about fashion and movies, as per me. So, I found a list of such topics which I wanted to merge, and then I told the model to merge the topics. So what I have done is whatever I think could be grouped, let's just group it so that we bring down our classification list even further. And that brought down my classification list to 28 topics. Okay. So that was one thing I did as well. And one other thing that I had observed was in the topic zero, I felt like this topic was huge and it could be split into more than two categories. Like it is not just so right now it could be fashion or it could be movies also. It could be anything. So I wanted to dive deep into this topic and understand, can I split it? So that also can be done. So I did that using a word cloud. Now, I'll talk about what explainability is, but this is one of the aspects of explainability in natural language processing, right? So my model has this topic that is defined, which is topic zero. But what are the words that it is considering in this topic? How, like, if I were to explain this topic to a stakeholder, how am I able to explain this topic? And one such tool is word cloud. So now if I look at this word cloud, I clearly see that fashion is a bigger category because apparently there are more words, and movie is a less bigger category. And you can still split it because there's a big word photos, which could mean any celebrity photos or fashion photos. It could mean anything, right? So what I did was I was like, let me split this further. So I specifically took out this topics data and trained a separate model on that particular zero topic number. So there was 17,000 entries in topic zero. So I retrained the model with just that particular topic to separate it out, right? So now you can see that from that specific topic, it has been able to separate it out into fashion, music, and Disney princesses, and some of them funny tweets as well, and so on and so forth. So there are hidden categories hidden within this topic, which I thought were relevant for me. And also here also I thought that the last four topics were, could be merged into a miscellaneous. So I grouped them. So this is how you can fine tune it as per your requirement and as per your domain specific needs. You can relabel articles, you can merge topics, you can, at some point give it anchor words as well, which is the next step that I'm going to do when I'm going to do a second iteration of this. So finally, I have, and at the end, like once I did separate out the topic zero and its categories, I combined the results from both the models, the model that I trained on the entire data set and the model that I trained just on topic zero. And how I combined for topic 0, it has to take the topic 0 specific model probabilities. So all this is plain code to merge the two models, which you can go through on your own. And finally, after I merged, I created these specific labels. Now the model has generated these random names, right? Basis the top 4 words. I don't want the random names. So I just, added my custom labels and assigned them. And finally, after I merged everything, this is what I had. This was my final output, which I was okay with for the first iteration. I was like, let's go with this. So you can see American airline incidents is the topic. This is an article about funny tweets, and it has been marked as funny tweets. This is another article about funny tweets, and there are some unknown articles also. What are these unknowns? Now, when you're doing topic modeling, right, the model assigns -1 to those articles where it doesn't know or cannot categorize. Like it is not really sure what topic it should fall on. So it groups all those under -1 category. Okay. So that is -1 topic. So I have this final list. Now, what this final list has and what is important for me is the document, what is the label, and what is the probability with which the model is sure of its prediction or its label, right? So you can see the model is 100% sure in this particular example that this particular article is about airline incidents, and that is correct, right? So I don't want the supervised model to be trained on all examples. I want it to be trained on only high confidence examples. And by high confidence, for me, high confidence was probability that the model is sure about the label greater than zero point 0.7. So 70% sure, if the model is 70% or more sure about the particular label, I am going to consider that label as a high confidence label, and I'm going to get only those as an input for my supervised model. So that's what I have done here. I have filtered only those with 0.7 probability, and this is my final output is 73K samples. So can you see we had 200K examples, and we were able to map 70%, 30% of the data with 70% confidence almost. And you can make this 90 also, as per your need, as per your threshold of error margin, as per your business requirement. So I got unlabeled data. From unlabeled, we have reached a place where we have marked 1/3 of our data and labeled it. So that's the first step that we have done. So this is the output of our unsupervised model. And from this, I only care about the document and the label for my supervised model right now. So I just take those out, and this is what I was looking at, what all categories are present. And you can clearly see fashion and politics are, more in this particular category. So then I quickly saved this output. This is the output of my unsupervised model, which are my high confidence labels, which I'm going to pass to my supervised model, which is our BERT classifier. So this is our step 2. Now, the input to this is our file output that we saved from the first step, which is the supervised file. And you can see this is the same output. So there's a document and there's the label. So the first step, of course, and with every supervised model, we have the same step. We do data pre-processing, we do encodings if needed, and then we finally train our model, right? So I'm preparing the documents and text labels, and I'm encoding the labels because the model understands numbers, so it won't understand airline incidents. So I'm just encoding airline incidents as 0. Okay, so I am encoding the labels. Now my data is prepared. Then, like every supervised model, I will break it into train, test, and validation split so that I can, find out the accuracy of my predictions. And I have divided that into train, test, and validation set. Then I'm creating the encodings for my training and validations using a tokenizer. And you can look at what all these steps mean in detail since we are crunched with time. So I'm not really going into the concept of it, but these are the five or six things which you will do in every model you will build. Okay. So I have the inputs prepared, I have the encodings created, I have the model defined, which is my next step. So the model is bird classification model. And here I'm going to add the hyperparameters, and this can change. And this is what where you will look at when you will look at the final output, and you would want to, like tune your model, right? So I'm going to maybe change the learning rate, or maybe change the error margins using the epsilon. And this is where we define the hyperparameters, define the model, and then this is where I'm training the model. So I'm training it on two epochs. It will run around the entire data set twice and train the model on the labels that we generated, right? So out of this, what is the output? I'm going to get my own LLM out of this. So this took around 5 to 6 hours because I trained it on my PC, on my Mac. So it took around 5 to 6 hours. And the output is my own LLM with such and such huge amount of parameters, which is trained specifically on the data that I gave it, right? On the domain specific nuances which I trained it on, like on the first pass. And there are going to be iterations of this, which you're going to keep on working on. And finally, I will save this model. This will create 5 files for you. Right now, I don't have it on my system because these were huge and I downloaded this repo from GitHub. But if you see, once you save it, it will create 5 files for you. And 4 of them are listed here. It will also create an h.h5 file, which is your model, which is a huge file. You can't check in into GitHub unless you use LFS. So I couldn't check in, but if you run this model and you'll find the model, so you can save it to your directory and you can use it. You can load it like you load a file, and then you can use it to make predictions. So I wrote this prediction function, and wherever the prediction probability of the model is less than 0.5, I am going to mark it as -1 so that I know the model is less than 50% sure. And this prediction probability is of the supervised model. Okay. The supervised model is telling me that it is such and such sure of the probability. Now, you have a probability from unsupervised model and you have a probability from the supervised model also. So that you can, play with it in the next steps, which is what I'm going to do later. Uh, but the sky's the limit in how you tune and how you feed and how you train your model specifically when you don't have label data, right? So since we had encoded the labels, I retained it back. And then finally, like I reassigned the textual categories, and this is what the model has generated. So this is the news article. And for that, this is the model's label, and this is the confidence value. So 99% sure, 100% sure. And you will see out of the 10, 7, it has been able to mark correctly. The first three are not, the first two are not correct, and this one is, it's not 100% sure. The other 7 are okay. So now the next steps for you would be to, like tune it, look at the probabilities from both the supervised and unsupervised, pick which you think is correct. Maybe choose the more confidence ones from unsupervised and supervised. So you can decide your approach and play with it, right? So that is the end of our code essentially. And one more thing that I want to touch upon, which was explainability in NLP. So let me share my presentation again. Mm, just a second. Okay. So we talked about explainability in NLP. So what does it actually mean, right? Explainability in NLP, it refers to the ability to understand and interpret how a language model makes its decisions or predictions. So the point is to make the process clear and transparent for us, so we understand how the language model is trying to make the decisions. And why is this important? Because we don't want to rely completely on the model. We want to guide it as per our domain specific requirement, right? And to do that, we need to know how the model is making decisions so that we can correct it whenever required. So this way, it helps us to build trust in the model's decisions. It helps us identify any biases or errors the model is making and intercept it and correct it. And it also helps us to train it as per our domain. And this is where the human aspect of machine learning is most in play. And hence, explainability is extremely important, because if you were to explain this to your stakeholder or anyone in general, then you would need these particular tools. And we saw one such tool. Like, I used the word cloud to explain what the topic was, and in grouping. And there are some other tools also, which I'm going to explore as a next step as well. So, talking about next steps. So, what's next in this model for me and for you also, if you were to decide to fork the model and play with it, right? So, the challenges that I faced were that there were ambiguous multi-label articles which we decided for, and that's where your domain knowledge comes into play and your expertise comes into play, right? And then refining noisy topics or topics which you want to split and stuff like that, right? So that's what I did as well, like splitting topics, merging topics, cleaning out the data, and so on and so forth. And I could do more. There are 100 things that you can do in this particular aspect. And the next steps for me, like I said, is to do semi-supervised learning techniques. Now I have predictions from both my supervised and unsupervised. So maybe I can use the supervised confidence labels to anchor and make the unsupervised a semi-supervised approach. So it all sounds a lot, but it's actually really simple. So you're using the models and its predictions to, like, feed good quality data again and train it again and again and again, right? Until you reach a point where you're satisfied with your output. And I would also like to explore advanced explainability tools. So I use word cloud, but there is Lime, Sharp, and some other tools as well, and good tutorials and libraries for you out there, which you can explore and play with the data with. And we are going to share the repository with you, so you can look at it, you can play with it, you can make it your own, you can plug in another kind of data that you have, and like work with it. So that's it from me today. I hope I have added some value to you, and you have learned something at least in this particular session. And I hope that you fork my repository and build something great out of it. Maybe we can collaborate as well and create a better classification model, a modular one maybe. So yes, thank you so much for your time. And thank you for listening to me. And if you have any questions, please reach out to your placement officers and they will get in touch with us. So thank you so much, everyone.